Hi guys, welcome to the 43rd video of the Love Babbar 450 questions series. So we have finished array, matrix, string, searching and sorting also. Just let me know if I have not solved a question in searching and sorting. I am not so sure. If it is, I will solve it definitely. Just let me know. And this last problem in searching and sorting, this is based on counting sort technique. Basically, array will have duplicate values and we have to sort the array. So counting sort is a method for that. I have made a video on counting sort and I put the link of the video in that video description only. So please check it out, okay? Don't feel I have not solved this problem. I have done counting sort. Today we have to start with a new topic, that is linked list. Now linked list is very important, quite challenging sometimes. In interviews they might ask you. Personally, in one of the internship interviews, my friends had got linked list questions. It was not so tough, but you have to think. And this topic, there are a lot of sources available online, so it is not hard to find an answer, but it is difficult to, build the logic on spot. So you need to know some methods. So linked list, okay. Now, what are the prerequisites for, moving ahead? So for moving ahead, I would say first of all you should know what is a linked list. Some theory you should know. Okay, some theory like linear data structure and what is the linked list node. So linked list node, what will this be? This will be data or value, whatever. Okay, and this will be a pointer to next node. So this is a pointer to the next node. So this is a linked list node. Okay. So these things you should know. So this is first thing, very important. And then what else you should know? Then you should know this also. Like you are given a vector or whatever array, and you have to convert this to linked list. So this is very basic thing. You should know this. Given array of integers, convert it into a linked list. So how will you do this if you're given an array? So you have to make a new node. So you have to make a new node every time. So this will be new node, and this you should give a value. Some value will be there, okay? And it should point to something, right? So you should know how to do these things. You should make use of head pointer, tail pointer. So these things you should know how to make a linked list with a given array. Okay. I won't be explaining that over here. I think you should read it by yourself. You will understand much better if you read it by yourself, actually, this topic, this part. So let us actually remove this and we will get started with our problems. And one more important thing is, while doing linked list problems, don't convert linked list to array and then perform operations. Like if you want to reverse a linked list, don't convert it into an array and then reverse the array and then make it again into a linked list. Don't do that. That is not going to be accepted in the technical interview. You may get accepted in coding round, but not in the technical interview. They want you not to use extra space most of the time. They want you to modify and do something with the linked list only. So don't, use vector. Like in when I was a beginner, I had done this kind of thing. See, this reverse a linked list question on lead code, I just put it into a vector and reversed the vector and then made a new linked list only. Just modified the linked list like that, but with the help of vector. This is not going to be accepted. Don't do this. I just wanted to show you that you should not do this, okay? So what is today's problem? Today's problem actually is first problem is write a program to reverse a linked list. So we will be given a head node and we have to reverse the linked list by changing the links. So today's first program is reverse a linked list. Watch the video till the end. I will also give you a homework problem. So please watch it till the end. Don't skip any part. And like the video, share it with all your friends, and please subscribe. Okay, I have to tell that now, so please do it. So reversing a linked list. So if the linked list is suppose 1 2 3 4 and 5, what should the reverse linked list be? And this is going to point to null. So it is going to be 5 4 3 2 1. Simple to understand, right? How to change the link? In this problem, difficult thing is what? Changing link. What do we do to change the link? So in these kind of problems where we have to change link, we need three things. First of all, we need three things. What is it? We need current pointer, we need next pointer, and we need previous pointer. We need these three things to change a link. Let me explain why. So suppose there is a node over here. It is pointing to another node over here. And there is a previous node which is pointing to our current node. So this is previous, this is current, and this is the next node. What we want now? We want this, right? We want the link to be changed like this, reversing. So what we should do for this? So first, let us concentrate on reversing this link. Let us not make it this, let us make it this way. How can we do that? So what is the code for that? Let us see that. So reversing a linked list in O of n and O of 1 time, we need three pointers: previous, next, and current. So we will run a loop until we don't reach null, and we will say next equal to currents next. So what does that mean? So let me redraw this diagram. Actually, let me make a better diagram now. Suppose this is the current node. We are going to say next equal to currents next. So next is going to come here. Okay. Then what are we going to do? We are saying currents next is equal to previous. So here we are changing the link. Currents next is equal to previous. We are going to change the link over here. So currents next was actually this link, right? This was the link. Currents next, this is the link. We are going to change this to point to the previous node. And then we will bring the previous node here. And then we will move the current node over here. So this is completely changed. And this is pointing to the previous node. So let me make a better diagram and I will tell you what exactly happened. Okay. So there is a previous node. There is a current node. And there is a next node. So what happened ultimately? We got previous over here we moved current over here, and we changed this link to this. Similarly, we will change this link over here, and we will make the last node as head. Actually, in GFG only, they have given a very nice this thing. You know, look at this. They have explained with animation every single step. So you can look at this also. So with this, you will understand, I think, better. The animation is nice. Otherwise, you can look at the code and understand also, it's fine. And don't forget to make head equal to previous. This is last step is very important. As I told, the last node will become head, right? So previous will have the last node. Previous itself will be the last node. So make head equal to previous. Okay. So this was the program to reverse a linked list. Now that we have learned how to reverse a linked list, why don't we go to next problem? Reverse a linked list of group of size k. We have to reverse every k nodes. We will be given a linked list of size n. We have to reverse every k nodes. So let us take the test case example and see what happens. So this problem is now reverse linked list of size k. Sorry, not of size k. Of every size of every k nodes or whatever. So the test case example is this. 1, 2, 2, 4, 5, 6, 7, 8, and k equal to 4. So first 4 nodes we will this thing, and then these 4 nodes. So when we reverse, we will get, I think so, this. And then reversing this part, 8, 7, 6, 5. So this is what the question is asking. Now that you have understood reversing a linked list, can you do reversing a linked list for every k nodes? I think it's going to be simple, right? What is it going to be? So let me just copy this, whatever I have solved here. So over here, again, we will need 3 pointers, current, next, and previous. Okay. And over here, we need count also. Basically, we will be first reversing the first k elements and then recursively doing it for the remaining k. For every set of k elements, we will be then recursively solving it. So this is common to the last problem, reversing a linked list. We need a count variable and we need to run the loop until these two are true. Okay. And then we will say if next is not null, that means there are some more nodes left. So if there are some more nodes left, we will be recursively calling the reverse function. What are the parameters that are going to be passed? It is going to be next node and k. And what should we return every call? This is important statement. We should return the previous node every call because previous node will be that time what the this thing, right? For every function before every function call, previous node itself will be our starting. So we have to return that. So reversing a linked list of size k, this is how you do it. There is not much difference. Just you have to know this thing. Why we are doing this? We are recursively calling it, and we are uh, doing for every node of size k. And what are we storing it with? We are storing it in heads next. Actually, there was one more part for this. Reversing a linked list iteratively we didn't do recursively. How to reverse a linked list recursively? So recursively, if we have to reverse, let me show you that. So if we have to reverse recursively, then what are we supposed to do? We will first check if current is equal to null. We will return null. We will check if currents next is equal to null. That means there is only one node. We don't have to do anything. We will return current. Otherwise, what we should write here, how to reverse this recursively? We have to do recursively. We should not do while loop. Over here, we should call the reverse function again on currents next. And we should say currents next is equal to current. And actually, I forgot one more thing over here. If currents next is equal to null, we have to make head equal to current, and we'll return head actually. Okay. So recursively, if you want to reverse a function, tell me if this is correct or wrong. Tell me if this is correct or wrong to recursively reverse a function. I hope you have watched the video until here. So please let me know if you have watched it over here. Recursively reversing. I hope you understood reverse a linked list of size k. So it is simple implementation of recursion only. Don't forget this, return previous and also heads next is equal to whatever you're going to reverse next. Because see, ultimately, we have to return the linked list, right? So our head should start over here. That is over here. So let us go to next problem. Next problem is detecting a loop in a linked list. Now this is a very simple problem actually. This is something called as Floyd's cycle or something, I'm not sure. Basically, if there is a loop in the linked list, how to find out? So for detecting loop in a linked list, so for loop detection, what should we do? We just need two pointers, slow pointer and fast pointer. This will move one step and this will move two steps at a time. So slow pointer is slow, so it will move one step. Fast pointer will move two steps at a time. If slow is equal to fast, we return 1 because then we have found an intersection, we have found a loop. Otherwise, if the entire loop ran successfully, we will return 0 because there is no loop only. So initially slow and fast are equal to head node, and while slow, fast and fast next is not null, we will increase slow pointer by 1, fast pointer by 2. If slow equal to fast, we will return 1. So if you want to know how this is happening, just take an example and you will understand by yourself. So basically, if you want me to do that also, I'll just quickly do it. Not such a big issue. So if suppose there is a linked list like this, and there is a loop over here. So initially slow pointer and fast pointer are pointing to the head node. So slow pointer will move by 1, fast pointer will move by, I'll take a different color. So suppose this is fast. So fast pointer will move by 2 steps. Slow pointer will move here. Fast pointer will move here. Actually, I did a mistake, I think. So I guess I did a mistake. 1 second, I'll just refresh it. So 1, 3, 7, 4, 6, and there is a loop here. So we will have 2 pointers, slow and fast. Okay, so initially slow pointer is pointing to head node. And fast pointer is also pointing to head node. So slow's next, it will come here, fast next will go here, then slow will come here, fast will go 2 steps over here. I think I'm making a mistake somewhere. Can you tell me in the comments where I did a mistake? So where am I doing a mistake? Initially slow and fast are here, okay. No, initially slow and fast are pointing to this. So first slow will come here, fast will go here. Then slow will be here, fast will go and meet here. So both will become equal. Fast will be here, not here. That is the mistake. And fast will go here and again come back here, and slow will be there only. So slow will move by 1, fast will move by 2. So I hope you could understand what the problem is. This is just Floyd's detection cycle, okay? And homework problem for you is find a starting point of a loop. This is based on detecting a loop only. So one homework problem for you is this. Please try to do it by yourself. So if you like the video, please like, share it with all your friends, subscribe to the channel, and please let me know if you're liking it. Take care, have a good day, stay safe, stay tuned, bye.